So today we're going to focus on understanding that I, the imaginary unit I, and do some different operations with that I, right? So we're going to do some how to add, subtract, multiply, and divide. We're going to know how to work with the I unit, the imaginary number, pretty well. So I introduced it the other day a little bit for you guys, and then I'm going to show you how to use that, how to come up with complex solutions in certain quadratic equations. Okay. So let's start with the basics. Notice, like if I took the square root of 100, it's technically plus or minus 10, right? A lot of times they just keep the positive version of it, but you got two roots out of a radical, okay? When you're just simplifying those, a lot of times they just keep the positive version of them, though. So like in an equation, you're going to want to put the plus or minus in there, okay? But technically, negative 10 is also the square root of 100. Because negative 10 times itself is 100. So be careful there, okay? But a lot of times we'll just keep that positive version, like I said, when you're simplifying those. But like for this one right here, if I typed in the square root of negative 100 in my calculator, you're going to show up as an error, right? So we talked about how I represents the square root of negative 1. That's how mathematicians define a negative radical. So there's a way I can express this, right? So what I could do is I could literally write root negative 1 times root 100 and just pull out the square root of negative 1, and notice that is I, and then the square root of 100 is 10 if we just kept the positive version of it. Okay, so notice you could just write 10i from that expression, right? So I'm just going to write it as 10 first and then the I second. Okay. So we also see there are actually some neat things that pop up here. Like if you notice, like I squared represents the square root of negative 1 times itself, right? So that's just negative 1. The square root of negative 1 times the square root of negative 1. The radicals undo each other, and you're just going to get negative 1. It just keeps what's under the radical. Okay? So I squared is negative 1. So you can make some iterations from this, right? You can say, well, I want to figure out what I cubed is. And I want to know what I to the fourth is, right? And so forth. Well, you can use properties of exponents to split this up. So like I cubed is the same as I squared times I. Okay? So we know I squared is negative 1. And then we know it's I is multiplied with it, right? So the answer is just negative I. So negative I is I cubed. Okay? If I wanted to find I to the fourth, I could split that into I squared times I squared, which adds to I4, right? So notice you're going to end up getting negative 1 times negative 1, which is just 1. Okay, so if I wanted to find I to the fifth, I could just split it up into any combination of i's. So I could do I times I to the fourth. That's I to the fifth, right? And so notice I to the fourth, we already figured out was 1, right? So all it is just 1 times I, which is I. So I to the fifth is I. Okay? If I wanted to find I to the sixth, you could do lots of different things. You can do 3i squareds. You could do an I5 times an I1. You can do an I4 times an I2. It just depends on what you want to do. So notice like this one would just be 3i squareds, right? So if we know I squared is negative 1, it's just negative 1 multiplied 3 times. So that's just going to be 1 times negative 1, which is negative 1. And so you can keep the pattern going, right? So, if I wanted to find I to the 10th, I could just take I squared and multiply it 5 times. You could do that 5 times if you wanted to. 1, 2, 3, 4, 5. And so I squared is negative 1. So it's negative 1 multiplied 5 times. So there's lots of different ways you can figure I to the 10th, right? So notice that becomes 1, that becomes 1, and then the negative 1 at the end makes the whole thing negative 1. So negative 1 is your overall output. So you just get different looks at those. So I just wanted to show you guys that first, okay? So let's actually simplify these. We'll just keep the positive version when we simplify them, okay? So right now we'll just keep the plus. So like for this, the square root of negative 25 you can rewrite it as the square root of negative 1 times the square root of 25. And so notice that becomes I times 5, which is really just 5i. Okay? Because you just pull the negative 1, square root of negative 1 out. So like for this one, that's a perfect square. So you get root negative 1 times root 36, which is really just 6i, right? So this becomes I, and that becomes 6i. So like one like letter C, you got 48, right? So the perfect square would be 16 and 3, right? So you're going to do the same rules before. We're going to put the perfect square first, and then we'll put the non-perfect square second. So 3, and then just split it up like that, and then put the negative on the 3. Okay? And then notice that becomes 4. And then the square root of negative 3 is just, notice you can't break down root 3, right? And just pull the negative 1 out, so it's 4i times root 3. Okay, so the negative 1 becomes I out front. So 4i root 3 is your answer there. So like on one like this, you got the negative 5 out front. This piece right here, the square root of negative 9, you could think of as that's a perfect square, right? So that just becomes negative 5i times 3. Okay, so it's really negative 15i in that case. Okay, because remember, this whole piece became 3i, and then multiplied by negative 5 out front. So you just got to get good at kind of simplifying those first, because we're going to use that skill when you solve these, right? So now when we solve quadratics where there's no bx term, you might get i's in your answer, just like we talked about the other day. So like if I square rooted both sides, notice you're going to get, and don't forget the plus or minus this time when you have an equation. When you simplify, you want the plus or minus. All right, you don't want just the plus. So notice I'm going to get, this is going to become 4i, plus or minus 4i. Okay, so what that means is there's no x-intercepts. Okay, so those are my two solutions, right? So like if I did the same thing on this one, there's no bx term. I just solve for the x squared first. Notice I got negative 100 over here, and then I square root both sides. So notice you're going to get plus or minus 10i. Okay, and remember when you square root, you always get a plus or minus on that side. The negative pulls out as I. Okay, so another example, like in letter C, no bx term, I just minus 26 over 2x squared equals negative 36. Divide by 2, x squared equals negative 18. And then when you square root, notice you're going to get x by itself equals plus or minus over here. 18 splits into 9 and 2. So I'm going to put the perfect square first, and then the non-perfect square second, and put the negative on the non-perfect square. So notice your final answer should be plus or minus 3 from the 9. This piece becomes, pull the I out front from the negative inside, and then keep the root 2 at the end. So plus or minus 3i root 2 is your answer. Okay? So what we're learning is that a complex number has two parts. It has a real part and it has an imaginary part. So the real part is the number out front. That's like the integer out front, and then the imaginary part always has the I attached to it. Okay? Now, when you get in a trig pre-calc, you're going to learn how to graph a complex number. It's kind of like just graphing basic points. You go over, on the x-axis represents the real number, and then the y-axis represents your imaginary part. So it's pretty simple, but that's not something I want to focus on for now. Okay? So when we start looking at these, what you're seeing is there's kind of an organized way to represent a complex number. Okay? So what we see here is that a real number always has, that's that A part out front. Okay, so that's like, those are like, real numbers can be rational, expressed as fractions. They can be also irrational numbers too, like pi and root 2. Okay, a real number can also be an integer, like negative 1. Okay, so we just kind of have to, this is kind of what you've been playing with so far in your math career, is these real numbers. Okay, but now we're looking at these imaginary numbers with i's in them, this a plus bi part, right? The b can't equal 0. So in other words, a complex number is going to have both of those parts. It's going to have the real and the imaginary part. Real and then imaginary. Okay? You could have a subset of a complex number where it's only pure imaginary. So in other words, the real part is 0, and then you only have just an I part to it. Okay? So we have to kind of pick that up right away. And sometimes we'll learn later on, like, you guys know how to find conjugates of, you know, complex numbers, right? So like 2 plus 3i, its conjugate would be 2 minus 3i. The conjugate of 9 minus 5i is 9 plus 5i, right? Turns out the conjugate of pure imaginaries is you just multiply it by itself. Okay? So like if I wanted to get rid of, like if this was on the bottom of a fraction, you just multiply it by negative 4i. Alright, the conjugate of this one would just be 6i. You just multiply it by itself. And notice the i's end up canceling out. And we'll talk about that a little bit later too. But that's important to pick up on. Okay? So the hierarchy of our number system goes like this. Okay? So if I'm talking about our number system, so you're talking about, so we're dealing with complex numbers on the top. Complex numbers. Okay, turns out you can either have real or imaginary. Okay, the real number system is kind of what you dealt with so far. All right, imaginaries is all that stuff with I in it, right? So a plus bi form. Okay, so if it's real, it can either be rational or irrational. Okay, so remember, like irrational numbers would be like pi, root 2, can't express them as a fraction. Rational numbers are numbers that you can express as a fraction. Okay, so like 1/2, 5/3, any whole number or natural number would apply. So you got some subcategories, right? So a rational number can be a lot of these other ones, right? So it could be, you could have natural numbers. You could have whole numbers. So natural numbers are basically all your counting numbers, including 0. Okay, whole numbers are basically your counting numbers. Okay, so keep that in mind. They're really similar. That just natural includes 0. Okay, and then you could also have, what's another one on this list? So we got all these taken care of: irrational, complex, real, whole, rational. Oh, and then we can have integers. And integers, remember, whole numbers and their opposites. So like -1 is an integer. Okay, so is 1. 1 is also an integer. Okay, so a lot of these are like, can be more than one thing. But notice in the real number system, this is all that you've dealt with so far, is either the rational or irrationals. So now we're just looking at these in imaginary numbers. Okay, so you're going to be doing some operations with them, right? So let's start to do, let's add 2 complex numbers. And so all you do, guys, is you actually put your real parts together and then your imaginary parts together. So those are easier. So notice you're going to get -1 plus 3, that's 2. And then 2i plus 3i, that's a 5i. So you just treat them just like normal variables. So there's your answer for that one. Okay. Now if I'm subtracting 2 imaginary or complex numbers, I got to make sure the negative gets distributed through both of these first. So that changes the signs of both of those on the right side. Then what I could do is then combine my like pieces. Okay. So notice 2 minus 3 is -1. And then you notice a -3i plus a 7i is a plus 4i. So there's our complex number added or subtracted that time. So you got to be careful when you're subtracting to distribute that negative. Okay. So like in one like letter C, I'm multiplying complex numbers, right? So I distribute the I through each. So I get -3i minus I squared. All right. Now one thing you always want to remember is I squared is negative 1. That is negative 1. And so that's something I want to show you in the front of the notes here, right? I squared is negative 1, guys. You want to remember that. Okay? So like when I look at this problem here, notice I get negative 3i minus negative 1. So notice that really becomes plus 1. So negative 3i plus 1 is your answer to that problem. And so you've got to be careful. Okay? So a lot of times I tell kids, it's, you know, you can see that, you can skip that step. If you know I squared is negative 1, a negative of I squared is plus 1. Okay? So like, let's do different looks at this so we get good at this. Okay? So if I distribute 3i through this one, in letter D, notice you're going to get 15i minus 21i squared. This piece right here is really negative 1 times negative 21, which is positive 21. Because remember, I squared is negative 1. Okay? So notice you're going to get 15i plus 21. Now you should write it in the standard form where the 21 goes first and the 15i goes second. So that's how I'd write my answer. So you got the real and then the imaginary part. Okay? So you might have a situation like letter E where you got two complex numbers in standard form multiplied by each other, right? So we would have to remember to FOIL or use the monkey method, right? So our first terms is 12. Outer terms is minus 4i. Inner terms is plus 18i. Last terms is minus 6i squared. And so this piece at the end is really going to be negative 1 times negative 6, which is positive 6. So let's rewrite this. 12, negative 4 plus 18. You add like terms here, right? So that's going to be positive 14i. And then this part becomes plus 6. And then what you can do is then add your like terms. So you're going to get 18 plus 14i as the result in that standard complex form. Okay? So try letter F on your own. See if you can FOIL this right. And notice they're conjugates of each other. You got 1 plus 2i and 1 minus 2i. So we'll FOIL. 1 minus 2i. There's your outers. There's your inners plus 2i. And then your last terms would be minus 4i squared. And so notice this piece right here, anything you got I squared, make sure you simplify it, right? So that becomes plus 4. I squared is negative 1 times negative 4 is a positive 4. So you're going to get 1. Notice outers and inners cancel. And notice this last piece becomes plus 4. So notice 5 is my overall answer. So sometimes you're going to get, what's interesting about this is sometimes the product of two complex numbers, when one is the conjugate, will actually produce a real answer with no imaginary part in it. So that's a good discussion to understand when you get, that's how you can get rid of imaginary parts, is to multiply by its conjugate. Okay? So like two other examples I want to go over is one like letter G and F. Okay? Because one like G here, you got to recognize, that you have two binomials, right? So in the bottom here, I'd want to FOIL. This is 1 minus I, multiplied by its conjugate, top and bottom. And the reason you want to do that is because, see, the bottom, when you multiply a complex number by its conjugate, the imaginary stuff cancels. And you don't have no more radical expressions on the bottom of a fraction. It becomes a real component like this. So notice the first terms become 1. Outers become negative I. Inners plus I, and then the last terms is minus I squared. So the bottom FOILed, notice the outers and inners cancel, and this piece becomes a plus 1. So 1 plus 1 on the bottom is 2. So the entire bottom is 2. Now we're going to do the same thing to the top here. We're going to FOIL the top. So the first terms is 2. Outers would be minus 2i. Inners would be minus 7i. And then the last terms would be negative 7i times negative I, positive 7i squared. Okay? So notice the 7i squared, that's negative 7. I squared is negative 1 times 7, negative 7. So notice you're going to get 2 minus 2, negative 2 minus 7 is minus 9i, right? And then minus 7. Well, 2 minus 7 is negative 5, and then keep that minus 9i in there. So notice the final answer is this, negative 5 minus 9i over 2. Or you could write it like this, negative 5 halves minus 9i over 2. I would take either of those answers. They're the same thing. Notice they can't reduce in any of those fractions. So you leave it as it's a real and then the imaginary part. Okay? So that's probably one of the toughest ones because you have to remember to multiply it by its conjugate. I'm going to put that down, times by the conjugate. So you got to know the conjugate is that 1 minus I, top and bottom. Okay? So like in letter F, what's interesting about this one is, remember one of our rules of simplifying radicals, and this is technically a radical. I is the square root of negative 1. So you never want a fraction or a radical on the bottom of a fraction. So to get rid of it, all you do is multiply by itself. Not by I squared, just by I. Its conjugate is itself when it's pure imaginary. Okay? So it's pretty simple, guys. What you would get on the top is the I distributes. So you get I plus 2I squared on the top. And then on the bottom you get I squared. See, we already know I squared is negative 1. So notice, let's look at the top here, right? This piece right here becomes negative 1 times 2, that's negative 2. And this piece becomes negative 1. So let's write our final answer pretty here, right? So you're going to get I minus 2 on the top, all over negative 1 on the bottom. Now technically, if both of these are divided by negative 1, it should look like this. I over negative 1. And then you can rewrite the double negatives as a positive, right? So it'd be plus 2 over 1, right? Which really becomes negative I plus 2. So in standard form, it would be 2 minus I. So you put the real part first and the imaginary part second. So 2 minus I is our final result. Okay? So be careful to do that correctly, okay? So one other look you might see is they might set an equation of some I parts equal to each other. So they're just trying to see you understand that the idea is if a complex number is written on one side and then the other, you just set the parts equal to each other. So you set the real parts equal to each other, and then the imaginary parts equal to each other. And what you'll see here is that you can figure out missing letters that way. So like when 2x equals 10, x is 5. And then when negative 7i equals yi, notice the i's cancel and you're left with negative 7 equals y. And so there's the y that would be missing. So those are pretty easy to find, guys. Okay? So what I want to see is that you guys do a good job practicing some of these skills, especially the operations, right? Where you're adding and subtracting and you're multiplying and you are doing some different versions of that might pop up here. Okay? So like for instance, like just looking at all these problems are pretty simple, but like even one like 20, multiply the complex number by its complex conjugate. This one you just multiply by 1 minus I. This one you'd multiply by 4 plus 7i. And then this one you would multiply by negative 3 plus 2i. Okay, so that's what they're trying to get to on those. So what I want to see today is that you guys do a good job practicing that skill. Okay, so I had the problems are the textbook for this first day. I want you to do a really good job practicing those and checking your answers. And then what we'll do tomorrow is probably do like a delta math thing, so we get a little bit better at these. Okay. All right, we'll see you guys later.